Welcome to ERC Tipsnology. In this video, we will be learning how to do the series parallel circuit with two voltage sources, but this time we will be using the superposition theorem. Now let's draw a circuit over here with two voltage sources and three resistors. This would be similar to the other circuits that we have drawn before that uses other theorems. Now, I'll put here 4.7 kilo ohms, just like what we did before, and 6.8 kilo ohms for the second resistor and 10 kilo ohms for the third. Let's put plus minus on this battery symbol or voltage DC, and let's put here 10 volts for the other voltage source. Now what I'll do is I'll use E1 to represent the voltage source 1 and E2 for source 2. Of course, we will put R1, R2, and R3 to label our resistors. Now, this is what we will use, the superposition theorem. This is another way to do the calculations of currents and voltages and other electrical quantities using this theorem. So what will we do first is to draw again the circuit, but we will be leaving just one voltage source. For example, I'll leave the left side voltage source 1 and I'll short the source number 2. So E2 will be shorted as a single wire, as you can see in the drawing now. This is our source 1, and instead of having 15 volts, we will not have anymore the 15 volts, and we replace it with a shorted wire. And then we keep the R1, R2, and R3, and there you go. You will see a series parallel circuit. And in this case, we can apply what we usually do for series parallel circuits. And that is, we will calculate the R total. And as you can see here, we have R total will be equal to the R1, which is in series with the 10 volts source, and then the R2 and R3 are in parallel with each other. So the R total will be the R1 in series plus the parallel resistors R2 and R3. And we will be calling this as the R total. So we multiply R2, R3, and we divide it by the sum of R2 and R3. And so we can replace the values for this. So we have 4.7 kilo ohms plus, this must be 6.8, not 4. So 6.8 kilo ohms plus the other, or multiply with the 10 kilo ohms resistor. And of course, we will add the 2, 6.8 plus 10. And there you go. We will be getting the R total. So let's use the calculator for this. 4.7 plus, we may cancel the kilo ohms now because anyway, all of them are in kilo ohms. Plus, let's use the fraction. 6.8, let's put a bracket first before the division, close bracket. And then we will go down, press the down arrow button. And then we write 6.8, or we press 6.8 plus 10 and then the right button and then close bracket, and you get the answer. We press the SD and we have here the answer as 8.7476. We can cancel the 1, so I'll just keep it 8.7476 kilo ohms. And again, this is the total resistance via or using only E1, or with reference to E1 only. We got the R total. Now, after we got the R total, we may calculate the I total or the I1. And the I1 with regards to source number 1, E1, will be equal to the total current or IT. So we can divide the I1 is equal to VS1, the source 1, divided by the R total with regards to source 1. So what is our voltage source, which is 10 volts, divided with the calculated the RT, 8.7476 kilo ohm. Remember, volts divided by kilo ohms would be milliampere. So we now have 10 divided by 8.7476, and we got 1.143170698. But we may cancel the remaining digits, and I'll just put here 14317 instead of writing the other parts. We can round up the 06, we put 1. Now, what we'll do is we will draw another, or we will get the value of I2. So based on this series parallel approach, the I2 is on R2 and it's going downward. So we will put the symbol E1 to know that we are doing this with respect to E1. And we can use now the current divider rule, which is R over R plus R, multiply with the current going into that junction between the three resistors, which is I1, or it could be I total. Now the R2, R3s are concerned, so if you want to get the I2, we will get the opposite resistor, R3. That's how we do the current divider rule. And then after that, we will be substituting the values of this. So we have R3 equal to 10 kilo ohms divided by the R2, which is 6.8 kilo ohms plus 10 kilo ohms. And then we multiply this with the I1, which is 1.14317 milliamperes. And then what we'll do is we will be using the calculator, of course, to solve this problem. So we will put here 10. We will multiply 10 with the 1.14317 milliamperes. Multiply it with 10 and we got 11.43. And we divide that answer with 6.8 plus 10 kilo ohms, but we can cancel the kilo ohms for now. Anyway, all of them are kilo ohms. And then we got the answer of 0.6804589. So this is, by the way, kilo ohms multiplied with milliamperes will be volt, divided by kilo ohms, that would be milliamperes. So we got 0.6804559 milliamperes for our I2 with respect to E1, or without E2. Now the last current we will calculate is I3 with respect to E1. So we have I1 minus I2 by Kirchhoff's current law, because the other one we used the current divider rule before. So now we substitute the values of I1 and I2 with it, and we will be getting the value of I3, 1.143171 minus 0.680459. We will get the value of 0.462712 milliamperes. And there you go. We have taken, or we found already, the values of all the three currents with respect to E1. Now the second step in superposition is to now cancel the first source, and then we will keep the second source. So we have to draw it again so that it will be easy for us to analyze the circuit. So as you can see here, I draw the E1 without the battery anymore, or the voltage source, but a shorted wire. And then we keep now the second source, E2, which is equal to 15 volts, and we connect the other parts of the circuit, which is R3, R2, and R1. Now remember that the total current, or I total, will come from the 15 volts power supply. So we can write here a current symbol to represent the current through R2, and we'll be calling it as I2. Okay, that's the equal to I total, that I2. and we have E1 and we have I3. Or we have I1 and we have I3. As shown here, we have to calculate first for the R total with respect to E2. And R1 and R3 is now the one parallel to each other, because R1 is connected to the ground, including R3 connected to the ground. So we will be considering R2 as series plus the parallel of R1 and R3. That's what will happen there. And so the parallel of R1, R3 will be R1 multiplied with R3 divided by the sum of R1 plus R3. And let's substitute the value 6.8K and plus we have the value of 4.7K multiply with 10 kilo ohms. By the way, when you multiply kilo ohms with kilo ohms, that will be in the second power. Divided by the sum of 4.7 and 10, that would be kilo ohms. And it will still be kilo ohms. So the R total with respect to E2, we need to use the calculator to calculate for the answer. So we have 6.8 plus, let's put a bracket and a fraction part here, 4.7 multiply with 10 over 4.7 with a parenthesis there plus 10. Okay, and then you press the correct button on your calculator whenever you do this. Okay, and we got the answer of 9.997278912. That's our answer for the R total with respect to E2 or source number 2. But I just put here a 9.997 kilo ohms. Now we will get the I total with respect to the source E2. So that would be Vs2 divided by RT. And the value of Vs2 is 15 volts divided by the R total of 9.997 kilo ohms. Again, volt divided by kilo ohm would be milliamperes. And we got 1.5. No need to write 0.0450135 if you want. So we can keep it as 1.5 milliamperes. And so we now got the I total with respect to E2. The next thing to do is to calculate for I2. And to calculate for I2, we will be having here the I2 equal to R2. So the I2 is equal to R2. Oh, sorry. The I2 is equal to I total because it's in the same path, and the voltage source number 2 is in series with R2. That's why we got the I2 without any calculation. We just make it equal to I total. Now the I3, we will be using again the current divider rule, R over R plus R multiply with the I2, which is there, and the opposite I3, the resistor opposite I3 will be the R1. So let's substitute the values for this. So we have 4.7 kilo ohms multiply with the I2, which is equal to 1.5 milliamperes, and then we will get the sum of the two, 4.7 kilo ohms plus 10 kilo ohms, and we will get the answer for I3 after calculating. So let's use the calculator here. 4.7 in the fraction multiply with 1.5 divided by the sum of 4.7 plus 10 kilo ohms, and our answer would be 47 or 98 or 0.4795918367 milliamperes. So this will be our answers using these with respect to the second source. So now we have I3, we have I2. How will we get I1? We can subtract the I total or the I2 minus the I3 in our formula. So let's use I2 minus I3. And there you go. We have the Kirchhoff's current law. I1 equals I2, which is 1.5 milliamperes, minus I3, which is 0.479592 milliamperes. So let's calculate this one. What would be the I1 with respect to E2? Let's see. So 1.5 minus 0.47952 equals 1.020408. So what I'll write here are only 4 decimal places, but let's put also the 08. Anyway, it's only 6 fractional part there, or decimal point. There's a 6. There are 6 numbers. Now, looking back on the circuits that we have drawn with E1 only and we have E2, you can see that I1 have different directions. I1 is going to the right and I on the first one, and I1 is going to the left on the second one. So the I1 with respect to E1 is pointing the current to the right, which is our assumption. But definitely the two currents have different directions here in our circuit. So let's get the value of I1 with respect to E2. We got 1.02. So this one is the I2 with respect to the E1 and with respect to E2. But we will be getting first the I1, or the first current, or the current through R1, not through R2. So I'll be writing I1 will be equal to, let's see the direction of the I1, to the right, okay, and the other one to the left. Definitely we will be subtracting the values of this. It depends which one you consider as to the right in your analysis and which one to the left. So whichever or whatever it is, we will be writing it here. That's how important is the direction. And with whatever direction you have used, you need to keep it until the end of the calculation. So the I1 is pointing to the left here, and the other one is pointing to the right. To the right, that's why we subtract it. But we can also show it as we are just adding. We are adding the values of I1 plus another I1. We will get the algebraic sum of the two I1. So one I1 to the right, one I1 to the left. So the one to the right is from source 1 and the one to the left is from source 2. So let's put positive on the I1 with respect to E1 and negative to the I1 with respect to E2. And let's substitute what is our I1. It's equal to I1 with respect to E1. Let's see. So the I1 with respect to E2, I mean, is negative 1.020408 based on this drawing assumption. And we will add 1.143171. We would get 0.122763 milliamperes. And there you go, we got the I1 coming from the I1 with respect to E1 and coming from I1 with respect to E2. We just added them algebraically. And since they have different directions, what we did was simply like, you add them, yes, we add them, but we put the minus and the plus symbol. Now let me show you again the I2 going up and the other I2 is going down or coming down. So I'm sure it will be subtraction if they have different directions. Okay, so one is going up and positive, let's consider it like that. And the one going down, let's make it minus or negative. Let me arrange this paper before we continue. So we have the I2 with respect to E1. Where is it? The I2 with respect to this one. This is the I2 with respect to E1. And this is the I2 with respect to E2. So they are in different not location, they are in different direction. So the I2 is going downward and the I1 is going upward. So we got the difference in the direction. Now let's consider the upward as plus and the downward as minus. So this would be the plus and the other one is the minus. Sometimes you will have mistake. What happens is, so let's see the answer here. If we will calculate this, what would be the answer? Let's see. Okay, so we have minus 0.68 680,459 plus the 1.5, we would get 0.819541 milliamperes. And now you got your I2. So the remaining would be the I3. Let's have a look at our circuits. So we will be getting now the I3. That would be the sum or algebraic sum of I3 with respect to E1 plus I3 with respect to E2. So let's look at I3 here with source 1. It's going downward. And let's say this is the downward is minus and upward is positive. So both of them, the I3 in the source 1 and the I3 in the source 2, both of them are pointing downwards. So we will be getting minus plus minus or negative 0.46271 minus another answer plus minus 0.479592 milliamperes is negative, and in with respect to E1, so let's put it minus 0.462712. That's the value of I3 with respect to E1 plus the negative 0.49 or 0.479592 milliamperes. We got the answer of 0.942304 milliamperes. It's also good to write the complete answer so that your final answer will be closer to the actual answer. If you cut too much decimal places, then the possibility of having mistake will be there. So what do we have here now? We have VR1, we will be using Ohm's law. I multiply by R. So the current on R1 multiply with the resistance R1. So, or we can say I1 R1. We can also say IR1, which is the subscript, multiply with R1. It's the same anyway. I1 R1, I2 R2, and I3 R3. Now let's substitute the values. As you can see here, I'm writing down all the currents that we have calculated. And we are multiplying it with the resistors for R1, R2, and R3. Now milliampere multiply with kilo ohms would be volt. So no need to put the multipliers 10 to the minus 3 or 10 to the 3. Just remember that MA multiplied with kilo ohm would become volt. Just like what happened here, we have 0.5769861 volts. But we rounded it off to 3 decimal places or 3 fractional parts there. So 0.577 or 5.573 volts. So now we have the answers for our voltage drops on R1, R2, and R3. So what's next is let's just write the final answer for I1, I2, and I3, and we're done. And as you can see, we used around 30 minutes more or less in the calculation of this kind of circuit. Remember, we just did 3 resistors and 2 voltage sources. And these are the values that we get or that we got from the calculations using superposition theorem. So thanks for watching, everyone, and we hope that you will support our channel by subscribing to our YouTube channel, ERC Tipsnology. So have a nice day, everyone, and thank you so much for sharing your time with us and listening and watching. I hope that you can use this in your studies or in your work, whatever it may be.